Hey, for the people who just came on, can you guys thumbs up if you can see the Stepic on my screen? Okay, perfect. Thank you. All right. Welcome back, everyone. Thanks for joining us today. I don't know why I'm not showing up as the main camera on my end, but um, so today I'm going to go ahead and share my screen to go ahead and start the PSS session. So thank you guys for joining us. Screen one, go ahead and share. And then can you guys thumbs up if you can see the Stepic course pulled up? Okay, perfect. Thank you. All right. So today, on Tuesday, you guys should have probably covered lists and tuples with Danny. So it's kind of fun. Data structures are kind of like you guys have learned like how to call data, how to call a variable, and now you're kind of learning like how we can store data. You've learned what the data types are, and so now you're going to see like how we use the data. So today we're going to start with sets. Sets are really fun. It's a data structure. It's usually like an unordered bag of data. So in a set, there's no order to it. And really important, I don't know why they didn't underline it, is that they do not contain duplicates. So sets usually has like a set variable and only a certain amount, and it doesn't have duplicates. When you call a set, you would have like you would name your set like you would name whatever, like you call your variable. And then you call your set by saying set and then two brackets. If you know what you already want to put in your set, like if you have a bunch of data, like data points in a CSV file or whatever, you can already like, call it my set equals. And then instead of just saying set with the parentheses, you would just use curly brackets. And Python knows that that means that it is a set if you use curly brackets to declare it. And then it wants you to know that sets are unordered. Here, maybe I can make this bigger for you guys so that way you don't have to see. Okay. Is this a good size for you guys? Sorry, I'm on a new computer. Yeah. Okay. Okay. I think that's better. Okay, so sets again, unordered bags. You can think of it as unordered. And by that, I just thought you can't index into it. Like with strings, you guys could index into certain parts of it. You can't index into a set just because it's unordered. Okay. But you can add things to sets. So once you call a set, like you can add things to it, just like you can add data points to something. So when you insert into a set, the way that Python does it is by doing dot add with whatever you want to insert inside of the parentheses. So here you have your set. They're declaring it. It has three values in there. It has goodbye, which is a string. It has an integer, and then it has a Boolean. Sets can store any types of data. It doesn't have to just be one type. And here you're adding two more values. You're adding two more strings, essentially. You're adding fresh and data. And then here it says, as previously mentioned, sets do not contain duplicates. So if you try to add something to my set that's already in there, nothing will happen. So here they say my set add false. False was already part of this set. So nothing's going to happen here. False is still only in there once. Perfect. So then this goes to our first exercise break, which is in sets. It says how many elements will be in your set after your code executes. So let's look at this code. Here you have your set. They're calling a set. And then they're saying for I in range 10, so from 0 to 9, because remember the range, the end is exclusive. If I remainder 2, so if it's divisible with by 2, basically, it's even. If there's like 0 remainder, essentially, if you're dividing it by 2 and there's 0 remainder, it's even, else it's odd. And so it's going to go through each part of, it's going to go from 0 to 9, and it's going to see if it's divisible, if it has any remainders, if it's even or odd. And then it's going to keep adding them to the set that you're adding, that you created. So at the end, you would think that maybe it has like a bunch of evens and odds, but because it's a set, it won't. It'll only have two things in there. So let's go ahead and visualize it. Here you have your set. First I is 0. 0 is not divisible, or it is even. And then we have odd. 1, 2 is even. 3 is odd. But notice that our set here is not increasing. There's always only going to be even or odd because those are the two things that are in our set. We can't add more to it. So we're going to go ahead and put 2. Perfect. Okay, and I'm going to move these over here. Okay. So now we want to know, like I said, you can't index into a set, but you can still access stuff in a set, right? Like you want to be able to access data that's in your set or whatever value you have in your set. And you can't use the indexing operator, right? Because it's unordered. But there are 2 common ways that you can access your set. And you guys have kind of already learned about them. The first one is looping. You can use a loop, a for loop, to go into a set like this. You would say for item in my set, or for I in whatever you set as my set. It could be named whatever. You would do a code. So whatever you wanted to do, like, if the item, if the value is a specific number or a specific like Boolean, you could call it out there. And here it says that the iterator variable in the for loop stores a copy of the current element. So because of this, like it'll keep going through it. And then you can also check if an item exists in a set. So we also check this. Remember, this is like if something is there, it's true. So this is your if statement. So if item in set, my set, do something. So like if it's true, kind of a Boolean, if it sees it in there, you can go ahead and do the code that is in there. It becomes logical. So let's go ahead. You can also update because sets are unordered bags. There's no way to update a value. So you can usually update by deleting an item with an old data, which you'll learn how to do in the next steps, and add a new item with the updated data. Okay, so here we have 2 sets. It's our first code challenge, and it's kind of a challenging one here. We are interested in the relationship between sets and their data. One example is called symmetric difference, which is defined as the set of all elements that are in one but not both of the given sets. So you can assume that sets 1 and 2 have 2 sets of just arbitrary int values, and we're trying to print the symmetric difference of the 2. The example they gave us here, set 1 has 1, 2, 3, set 2 has 2, 3, 4. And so the program is trying to say what is in one but not both. And then the program outputs 1 and 4 because 1 and 4 are found in not both, are found in just unique ones. So it's like the difference between them. All right. So in order to do this, the way that I approached it was by first, I kind of created a variable called symmetric difference. So let's go ahead and copy this and put it over here. Oh, okay. All right, guys, new computer. So I'm going to just call it symmetric difference equals, and I'm going to make that a set, right? Because we're learning about sets and you don't want to have double of something. It's going to be a set. And then I'm going to just do 2 simple for loops. I'm going to say for, instead of doing I, just to make it really clear for you guys, I'm just going to say for number in set 1, right? Because set 1 and set 2 have already been declared here. We don't have to declare them. But we can go through them. So for number in set 1, if number not in set 2, right? Like if you can't see it in set 2, we're going to go ahead and add it to symmetric difference. So I'm going to call symmetric difference. And the way we add is dot add, and I'm going to go ahead and add number, right? Because it's whatever, for whatever number as it's going through set 1. You're going to go ahead and add that number at that point. And then we have to do it for the other one as well. So we're going to do another for loop. So for number in set 2 this time, right? If number not in set 1, the number was not in set 1, then we're going to go ahead and add that number to our little set that's called symmetric difference. We're going to go ahead and add that number. Okay. And then I think it wants us to print the symmetric difference. So I'm going to say it's just going to be another for loop, but this one's not really, ooh, I don't know why it's doing that. Sorry, guys. Okay. This one is for a number in symmetric difference. I'm going to go ahead and just print the number, right? Because that's what we want to see. We want to see the numbers printed in this. So let's go ahead and see if that works. Perfect. If you guys have any questions about this one or like how I went through this, feel free to like, always use this code if you're following along, but also just kind of try to make sense through it. I used for number, but here you can use for I or you as well. You can look at other solutions to see like how other people did it. Here, this person did something different. They did symmetric difference. Here they did a list instead of a set, and that's fine. They did it differently, but it still made sense. Here, this person did diff set. So always look at other options. All right, so now they're going to teach you guys about deletion, how you can delete something from a set. So remember when you add something, you do dot add. In order to delete, you do dot remove. This will be kind of important because different like sets and dictionaries and lists have different ways to add and remove things. So here, the way that you would remove it is you would call your set. So whatever you named it, here's my set. And then you would just do dot remove and whatever value in your set, Boolean, string, integer you want to remove. And so now your set looks like this. You can also do it in a for loop. So you can say like for item in my set, or with a if statement, logical statement, like if this item is in your set, go ahead and remove it. And that's like if you don't know already that it has that item in there. Let's say you're wondering like you have a bunch of data points and you don't want any of the data points above 10, but you don't know how many there are. You would just say like if item in my set, if item is bigger than 10, go ahead and like remove it. So just letting you guys know the logical ways to do it. Now we have a code challenge. Here is another kind of relationship between two sets. This one instead is the superset. So here we say set A is a superset of set B if all the elements of set B are also in set A. So in other words, set A has every element in set B, but can also have more. It's kind of like the big home where all the numbers are, and set B is like a little sub, but this has everything in it. That's why it's a superset. So again, assume that you have two variables, set one and set two, and they've already been defined with random arbitrary integers. And you want to delete as few elements as possible from set one, so from set two, so that set one becomes a superset of set two. So we want to make sure set one has set one has everything inside set two, but not add anything else to set two essentially. So here set one is 1, 2, 3, set two is 2, 3, 4. All they would add, you could delete 4 from set two, or you could add 4 to set one, and then it becomes a superset of it. Okay, so let's go ahead and use the remove. Okay, so for this one, I'm going to go ahead and do another set. I'm going to call it remove. And I'm going to go ahead and declare it with my 2 brackets. And then I'm going to do another for loop. So I'm going to do again for number in set 2. If number not in set 1, right? If the number is not in set 1, we're going to go ahead and remove. We're going to go ahead and add that to our remove list. So we're going to say remove add number. And now I have like a little list of like what I need to remove. And then I'm going to do another for loop, and it's going to be just for number in remove set 2 remove number. So essentially like for every number in remove, I'm going to go ahead and remove that number from my set 2. So now set 1 becomes a superset of it. Let's go ahead and run code. Make sure that that's working. Okay, so now 1, 2, 3. It's removing 2, 3. Okay, so it removed 4. Perfect. So let's go ahead and submit. Nice. Again, the way I did it might not like make the most sense to you guys, or if you weren't following along. So there's other ways that you could follow. Here, this person just called their superset and basically called the for loop in here, element for element in set 2, if element not in set 1. So just kind of going through lots of different ways is very nice to do. And I would make sure you do that. But again, if you liked the code that I used, make sure you can go ahead and feel free to use it. All right. So if you guys need to know more about sets and you're interested more, you can always follow the Python documentation. Sets are really important. And we use sets a lot I use sets a lot in bioinformatics. So I think it's good for you guys to learn about it. But more fun, I feel like, is dictionaries, or dicts as Python calls them. So we're going to go ahead and move on to those. First, I will check if we have any questions. Oops. Okay, no. All right, so now we are going to talk about dictionaries. It's called dict, short for dictionary. And here, again, pay attention. Dicts are unordered mappings of keys to values. Kind of like a dictionary where you look up a word and you see what it means. Similar here, it's kind of a key to a value. And you store it, you declare it like here. You have your variable, my dict, and you call it like similar to set with open brackets, but here you have dict. So make sure you're calling it as a dictionary. So dict with the open brackets. But if you already know what you want to put inside of it, similar to set, you can use the curly brackets. But here, notice that your dictionary has, it's kind of almost like a tuple. It has your key to a value. And here, keys can be anything that is a data structure. So it could be like a string, it could be an integer, it could even be a Boolean. And the values can also be like, it could be a Boolean, it could be a string, it could be an integer. So again, they can be random, and it could be kind of like it can contain lots of different types of data in there. When we want to insert into a dictionary, kind of like you wanted to add into a set, when you're inserting into a dictionary, the way that you would do it is here you have a call dictionary. Here you have 1, 2, 3 items in the dictionary. There are 3 keys with 3 values, and you want to add 2 more values. The way you would call it is you would have like whatever you called your dictionary. Here it's my dict. And in square brackets, so different than curly brackets, in square brackets, you would have your new key. And then you would say equals whatever value you want to give it. So it could be an integer, Boolean, whatever. And here they're doing 2 of them. So here they're doing my dict, square brackets, new key, wolf equals dog. And so now when you look at my dict, it looks like this. Here, now there's 2 more keys according to 2 more values. Okay, so the first exercise break, it says how many elements are in your dict after the following code executes. Here we have a list of that's called keys, and inside of it is just a list of different strings, red, blue, green, yellow, green, purple, blue. And here they're kind of declaring your dict is a dictionary. And then they're saying for key and keys, so for each item in keys, your dictionary key equals none. So remember when they did square brackets here, they're updating the dictionary. So essentially it's saying for key and keys. So for each of these values, you're creating a key for that value, and then you're making that key value equal none. So the key is going to be one of these values, and then the new value for that key is going to be none. So it's going to go through with it. So let's go ahead and visualize it so you guys know how many there are at the end. So here we have keys. We have our list. We have our empty dictionary. Our first key is red. So red equals none. Our second key is blue. Blue equals none. Then green. Green equals none. Then it's yellow. Yellow equals none. And then, it sees green again, and it does nothing. Green equals none. Then it sees purple, and it adds it to the list, purple. Then it sees blue again, but blue's already in our dictionary, so it does nothing. And so now at the end, it only has 1, 2, 3, 4, 5. So, and that's because it basically, as it saw green and blue, it basically updated it to none. And since it was already none, it didn't have to update it. Okay. So now we move on to the code challenge for this for dictionaries. Here it's kind of fun. It's like you're a little teacher and you're changing the grades or you're updating grades. So here you have a variable called raw grades, and it's already been defined as a list of string integer tuples. So it's a list, and inside of it are string integer tuples. You guys learned about tuples. It's basically like two data points that you're putting together, or two values that you're putting together. And it here the list represents the gradebook for the classroom, with each tuple being a student grade pair. So here each tuple is student grade, and it wants you to create a variable gradebook containing a dictionary that maps students as keys to their grades as values. So the example here, if raw grades is this tuple, right? This list of tuples, your program should set gradebook is now a dictionary, and we know it's a dictionary because of the curly brackets. And here we have again, the string to the integer, matching the tuples. Sample input. So for this one, I went ahead and followed it as it said. You want to create a variable called gradebook. Let's go ahead and do that. Let me bring it down. Gradebook equals dictionary. And notice how dict turns blue when I call it, just because Python knows, like it knows that it's a built-in function, that it's going to be a dictionary. Okay, and I'm going to say for pair in, and then here raw grades has already been defined, so I have to use raw grades. So for pair in raw grades, yeah, student equals pair. So basically it's saying like for tuple in raw grades, but I'm saying for pair in raw grades. And saying student equals pair 0. So student is the first part of the tuple. And then grade is the second part, which is 1. And then I'm going to call gradebook. I'm going to call gradebook, which is our dictionary that we have, student. So here I'm calling the student, which is the first part, as the key, remember? If you have it in square brackets, that it is the key. And then I'm updating them to make sure that it equals their grade. And the grade is the pair 1. So here it's going to go through each pair, and it's going to see like, okay, the first part is student, second part is grade. I'm going to make a dictionary, and the student is going to be the key, and the grade is going to be the value. And that should be it. Perfect. Again, sometimes it feels like a little more challenging than it should be, but that's when you want to look at other solutions and how other people did it. Hopefully this made a lot of sense to you guys. So then sometimes you want to extract values from your dictionaries, right? Like we want to access it just like we wanted to access our sets. In order to extract values, you can do kind of 2 different ways. First, you could create a variable, whatever you wanted to extract. This one's called extract fox. And then you basically could call your dictionary square brackets of your key, and it will return whatever value of that key is. It's going to be this, right? Like it's going to say extract fox is not going to equal a string that it says fox. Here, extract cat, they're going into my dictionary and they're extracting the key meow. So now extract cat is going to equal cat, the string. Same with extract red, my dict 3, not because it's in position 3, because remember they're unordered. It's because the key was 3. So now it's red. You can also do it using a for loop. We love our for loops. So for current key in my dict, print key is current key and value is whatever the current, you would call my dict current key. And that's calling the value, right? Like, because you're calling my dict at that key. So it would print out what you want. You can also update. You guys already kind of saw this, but here it's teaching you again. You guys saw this in that question earlier. But essentially, if you want to update something in your dictionary, you kind of have to be a little careful because here you have in your dictionary, your key is 3 and the value is red. And all you have to do is call your dictionary with the same key, but the new value, and it'll automatically update. It won't like say, like warn you, like, oh, hey, this key already exists and it has a value. It'll just automatically take your word for it and update it to whatever you want. So it can be a little dangerous. But just know that that's how you would update something. You would just call it the same key, but then whatever new value you want. Okay, so now it leads us to our final code challenge for today. It is another gradebook challenge. Here again, gradebook has been declared for us. It is this time, it is a dictionary mapping string to integer values, kind of what we did last time. We created that dictionary. And here it also has a variable called updated grades that has already been defined as a list of string integer tuples. So this was kind of like we're going backwards from what we did before. So here we have a grade book. It's already a dictionary. Like the teacher already has her keys to her values, and updated grades are a tuple with the same name, basically, and then the new value of whatever updated grade it is. So essentially, this code wants you to update gradebook according to updated grades. And just as an example, if gradebook was Sarah had 90 points and Billy had 85, but updated grades, Sarah got a 75 and Billy got a 60, then the new gradebook was Sarah got a 75 and Billy got a 60. It's not asking you to do an average or anything. It's just asking you to update it to whatever new grade it is. Okay, so for this one, I said for tuple in updated grades. Updated grades is already a variable, and I'm just accessing the tuples in there, right? Student equals tuple 0, similar to last time, and grade equals tuple 1, so the second part of it. And then I'm just going to go ahead and update gradebook. And I remember when you can update just by calling the key, right? So here's student, calling the student from the tuple, equals grade. So essentially here, you guys, I basically iterated over each tuple in updated grades and took the student name as the first part, so 0, and then the grade, which is the second item in the student's grade. And then I just updated it where the key is the student's name and the value is their grade, and it updates it. So again, if you guys have any questions, let me know. If not, that is the end of this one. And then it teaches you about deletion. So also important to learn about deletion and make sure you guys review these. It's not part of the PSS, but make sure you guys go over how you would delete. You could use either the word delete, del, or you would use this fun kind of pop, where you would call your dictionary and then you would do period pop in whatever key you wanted to delete. So it's kind of fun, this little pop. And then again, there's more information about Python. And now it goes on to comprehension. And then this is just for you guys to do since there is no code challenges up here. So let's go ahead and I'll stop sharing. I will stop the recording.